Okay, on equation of a circle, right? I'm like I was telling Mom, I went all the way through calculus, not knowing the concepts that I'm considering tonight, being dreadfully, abysmally math anxiety towards this, which is equation of a circle, function of a circle, whatever. I'm looking at this YouTube video titled The Equation for a Circle and How to Solve It for Y, right? So I went all the way through calculus, multivariate calculus. Not that I passed it, but I sat in the class for multivariate calculus at least. And got all the concepts, was introduced to partial derivative and double integral and all this stuff, Green theorem. And I never understood this concept of a circle, right? Stemming from the idea that from its very basic concept, right? One, x and y are both on one side of the equation. X and y are both on one side of the equation, right? How is this possible? Right? And this is happening in the very first chapter of algebra. I'm taking algebra for fun, and if I want to, which I think it would be nice if I do, I want to continue on this track at Road Community College for pre-med interest associate's degree, right? To include math, of course, but biology, chemistry, and physics, right? With a little smattering of extracurricular. Those are the solids, and then there's the electives, okay? Literally, this class I'm taking is an elective. Basically, it's not a solid. You have to go through this to get to the solid of calculus, right? And I say, why am I not good in calculus? Why did I get an A in calculus 1, calculus 2, and still I consider myself not good at calculus? And it stems from this concept right here, the equation of a circle, right? What does it mean to have x and y on both sides of the equation, especially a circle? More specifically, with respect to the equation of a circle, right? Are they talking about if you solve the equation of a circle, you get a point on the circle, or do you get the distance of a radius, or do you get the whole distance around the circle, the diameter, right? And this concept, the chapter 1, it introduces you with counting numbers and whole numbers and integers and things like this, right? Silly nonsense in 1.1. And then 1.2, they talk about distance formula. Now we're immediately going into, Pythagorean theorem. But the Pythagorean theorem deals with square root, right? And now we're dealing with variables in a square root situation, right? And I've never had trouble with the idea of distance formula, but the book shows the distance formula as you solve some, I guess. And then in the very next breath, it says equation for a circle. And why not? The module, x2 minus x1 plus y2 minus y1 equals distance, right? In the very next breath, that's 1.2, then 1.3 is circle. Not even 1.3. In 1.2, where the distance formula is, they have x squared plus y squared equals 1, right? Or more specifically, the point of the radius. The center of the circle being x and y, right? The center of a circle, the first point of consideration is x X and Y, right? Where you're going to put your compass, and then the minus x1 and the minus y1. That point is represented by a point on the radius, or the point on the circle itself, right? And then equals, I think it says r, which would be the radius, right? But why? Excuse me. In the distance formula, the result is the distance from one point to another, right? What is actually happening? The cloud is beginning to clear up. The fog is beginning to clear, right? What is actually happening in the equation for a circle? For a circle, meaning when you solve x squared plus y squared, what are you actually solving? But then again, if you solve for y, right, I guess if you solve for y, then you would be getting a point, right? If you solve, all right, y squared equals 1 minus x squared, right? And then somehow there's square roots of this, right? Square root to solve for y. And the guy says, when you do a square root of this y, you have to do absolute value. And it creates two equations. And I said to myself, the fact that he says that, and I've heard this before, you have to make two equations, a plus and minus, square root of 1 minus x squared, right? You have to, right? I say, literally the fact that they impose this, plus and minus, you have to take absolute value, and they call it formula, they call it function, whatever. The fact that they say you have to take absolute value is exactly why math deserves to be hated. That's what I'm saying. Stupid technical rules, right? I bet you, if I didn't take the absolute value, I could do it. I bet you, if I didn't take the absolute value, I could do it. I swear to God, I could solve this problem without taking absolute value, just like that, right? And I can. Y equals square root 1 minus x squared, right? And I say, oh, okay, I see. If I put half, 0.5 in x, right? I'm going to solve it. It's going to result a y value. And because I'm putting one value into x, I'm going to get one value out for y, right? Resulting in one line, which happens to be the top of the circle, right? So I go further to say, maybe a circle is so mysterious that it can't be solved with a function, an equation, an equation. It can't be solved with an equation because that's just the mystery of a circle, right? You can make two equations, but why should you have to, right? Make a process in math to where this is solved with one equation. How dare you not? How dare you not? Matter of fact, they did solve that. It's called polar equations. Polar equations solves exactly that, right? So I'm answering my own question. So that's like I said, the cloud is demystifying. The cloud is clearing. The cloud is clearing, meaning in algebra, to get the top and bottom of the circle, you need to make two equations, two functions, right? And do they say it in the book, right? They're not going to say it. They're not going to say it. In the book, finding equations of a circle, right? 49, radius of 7, right? What's it say? Circle. The circle with center HK and radius R has equation x minus h squared plus y minus k squared equals radius squared. Note, if the center of a circle is 0, 0, then equation simplifies. For example, the equation of the circle with center 0, 0 and radius 7 is x squared plus y squared equals 49, right? To say, in the very next breath, they should say, oh, they're not solving it here, I guess. They're not getting into top and bottom, right? Circles. Finding the center and radius of a circle. Find the center and radius of the circle. Graph each circle. X squared plus y squared equals 9. Okay. And that's just by child's play. X squared plus y squared means the center of the circle is the origin, or 0, 0, right? Equals 9. The square root of 9 is 3, right? Meaning the radius is 3, right? Equation, right? Graph each circle. X minus 1 squared plus y plus 2 squared equals 4. So you go right 1 and you go down 2. You go down, what is this? You go down 2. Okay, it's not square root of 2, it's 2. Down 2 equals 2. The radius is 2. Okay, right? What if they say straight out, don't worry about why we do this. This equation is not useful for anything. You will learn how to use a useful equation for a circle when you get to calculus 3 and polar equations, polar coordinates. But then again, in this book introduces polar coordinates. Conic sections, look at this. Further topics in trigonometry. But it doesn't, the multivariate calculus treatment of polar equations is what happens over time. You set things to motion in the matter of a circle and so on. That's calculus, is when things happen. When things happen, how are you going to measure things happening, not just sitting there waiting to be measured? That's calculus. So, change. The word calculus means change. Because the equation x, y, 9 can be written as x0, y0 equals 3, the center is 0, 0, and the radius is 3, the square root of 9, or 3. The graph of this circle is shown in figure 1, 2, 3. Which isn't right next to this. Oh, yeah, it is. Okay, there it is. For x1, 2, okay, it literally, yes, these are the solutions to the problems that I just mentioned, A and B. Okay. And I was right. Over to the right 1 and down 2, right, is the center, right? So, again, what's actually happening when you have an equation of a circle versus having a distance equation, right? A distance equation, that's the thing, is when you solve a distance equation, you're solving the whole line of the distance, right? The distance of a distance is distance, right? It's not, you're not solving for finding out at one point x, where is that point on the line y, right? Where's that point? You're solving the whole distance, unless you reconfigure the equation to solve for y or solve for x. Why not? And then you would be solving for a point, right? Right. You remember any of this stuff, Ma?
No.
No? Okay. Finding the equation of a circle. Find the equation of a circle that satisfies the conditions. Graph each circle. Radius 4, center 3, 5. Center 6, 3. With a point 1, 2 on the circle. Here we go. Here we go. That's, how do we do that? We put the point, we set the x and the y as that point. The x is 1 and the y is 2. With this point that is given on the circle, right? Is that true? Yes. Right? So, center, right, 6. Equation of the circle is 3, 5, 16. A graph of the circle is shown in figure 125. That's the first one, okay. B, first we must find the distance, right? This is very philosophical here. First we must something. First we must find the distance between point 6, negative 3, and 1, comma 2, right? First we must find the distance between the center, which is 6, 3, and a point, which is 1, 2, to determine the radius. To determine the radius, right? What if we didn't? What if we didn't? What if they're asking for the radius, right? Are they asking for the radius? No. Center with point on the circle. What if we didn't even solve the radius, right? What if we just put those numbers in this side of the equation and say who cares about the radius, right? Right. Yeah, that's approximate, okay. So 6 minus 1 minus 3 minus 2 square equals square root of 50, roughly 7.1. Since r squared, okay, the exact value, r squared, the radius squared, is 50, right? The equation of the circle is x minus 6 squared plus y plus 3 squared equals 50. Its graph is shown, right? Its graph is shown in figure 126, right? Now try exercises 89, 93, 103, 107. Right? How did I get past this concept in math and was able to do anything else in math? I should not have been able to do anything else in math without fully understanding this concept. Finding equation of a circle. The diameter of a circle is shown in figure 127, right? I mean, to further state, why do mathematicians consider both the top and the bottom half of a circle when they're doing this equation, right? Right. When they were considering the equation of a circle, why do you need both? Right. There's a better way to say this, but that's what I'm saying is if the circle x squared plus y squared equals 9. if the circle x squared plus y squared equals 9, right, is an equation x squared plus y squared equals 9. Why do mathematicians even entertain the idea that they're talking about a circle? Why don't they just say it's an arc of 180 degrees is the top of a circle, right? Why are full circles even considered in math, right? To say, and then of course, yes, blah, 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 in multivariate calculus or the next chapter, they're going to talk about polar coordinates, and polar coordinates don't have this limitation of x and y on the same side because it doesn't. I was introduced to polar coordinates in multivariate calculus in Road Community College after having gotten a withdrawal from multivariate calculus in Southern Oregon University, Cal State Monterey Bay, when I was a math major. Flipped out and got kicked out of that semester, so I was withdrawn from Spanish 2 and multivariate calculus, calculus 3, right? And I went back the next semester to the other school, Monterey Peninsula College, and one of the things that I was introduced to in that school was polar coordinates. I don't remember how to do it, but I know polar coordinates is specifically designed to make equations of circles. It's literally for circles. If you want to, if you want to measure distance around the globe, for example, you can do this without having to solve for circle. It's already it's in the mix already that you're talking about a circle, polar coordinates, right? And pi is in everything you do, right? In polar coordinates, or it's either in everything you do or it's implied. So you don't even need to solve for pi. It's just already there. And look at this, right? Why does this equation of a circle that we've been talking about for the last 20 minutes, an hour, why does this equation of a circle not have the concept of pi in it? Right? Right? If you're talking about the equation of a circle, why is pi not mentioned? Oh, okay. I could do these exercises that they want me to do, and I probably should do them. But will I be any closer to figuring out how to word what I'm actually frustrated about? That's what I'm saying. Right? Or I'll just be able to solve these problems, irregardless of philosophy and meditation. All right. I think I'm going to turn this off. I'm going to do these problems.